Ever wondered what the scope of software engineering is? It's a question that deserves some thought. After all, software engineering isn't just about coding. It's a multidimensional field that touches every corner of our digital lives. This discipline's importance cannot be overstated. From the applications that run on our smartphones to the complex systems that power our world, software engineering plays a pivotal role. To fully appreciate the breadth and depth of this field, we need to understand its vast scope. It's not just about creating software. It's about designing, building, testing, deploying, and maintaining solutions that meet specific requirements and quality standards. It's about managing stakeholders' expectations, ensuring alignment between business needs and technical solutions. It's about continuous improvement, ethical conduct, and professional development. So, are you ready to explore the fascinating world of software engineering? Excellent! In this video, we'll delve into the key areas that make up the scope of software engineering. Firstly, we have requirements engineering. This is the cornerstone of any software development process. It's all about understanding what the software should do and how it should behave. Picture it as a bridge connecting the real-world needs of users and stakeholders to the technical world of software systems. It starts with gathering requirements, which involves close communication with stakeholders to understand their expectations and needs. Then comes the analysis phase, where these requirements are dissected, discussed, and elaborated upon. Documenting requirements follows next, creating a written record that serves as a reference point throughout the software development lifecycle. This documentation is crucial as it ensures everyone involved has a clear understanding of the project's direction. Lastly, validating these requirements is essential. It ensures that what has been documented aligns with the stakeholders' needs and expectations. Remember, a software system is only as good as the requirements it fulfills. Requirements engineering sets the foundation for the entire software development process. Next up, we have software design. This is where the magic begins, where abstract requirements transform into a concrete game plan. In a nutshell, software design is a roadmap for how your software will be built. The first step in this journey is the architectural design. Think of it as the blueprint of a house. It's the high-level view that outlines the overall structure of the software system, defining the main components and how they interact with each other. But it's in the detailed design where things get really interesting. This is where each component, each module gets its own spotlight. The interactions, the functions, the nitty-gritty details, this is where they all come into play. It's like zooming in from the bird's eye view given by the architectural design to a microscopic view of each brick in the house. Software design is the bridge between what needs to be done and how it gets done. It turns the abstract requirements into a concrete plan. Moving on, we have software development. This is where the magic happens, where concepts and plans are transformed into tangible, functioning software. The development process involves the implementation of software solutions, using a variety of programming languages, frameworks, and tools. Each choice of language or framework has its own strengths, and is selected based on the specific needs of the project. In the world of software development, best practices are not just recommendations, they are the backbone of quality and efficiency. One such practice is modularization, the process of dividing a software system into separate, manageable modules. This promotes code reusability, making future development quicker and more efficient. Another key practice is code maintainability. This is all about writing code that is clean, well-documented, and easy to understand. It's about thinking ahead, considering the developers who might work on the project in the future. In essence, software development is where the design is brought to life, where ideas become reality. Now let's talk about software testing and maintenance. In the realm of software engineering, software testing is more than just a phase. It's a pivotal process that ensures the quality and reliability of the software. It involves a variety of testing techniques, including unit testing, integration testing, system testing, acceptance testing, and regression testing. Not to mention the use of automated testing tools to streamline the process. But the journey doesn't end at testing. Software maintenance steps in to keep the software up to date and reliable. It's all about making necessary modifications, enhancements, and bug fixes to existing software systems. It also involves managing software updates, patches, and version control. This continuous cycle of testing and maintenance is vital to address evolving business requirements and technological advancements. It's like the software's regular health checkup and grooming to ensure it remains robust and relevant. Testing and maintenance ensure the software remains robust and relevant. Next, we have software configuration management and quality assurance. Software configuration management is like the rudder of a ship, navigating the sea of software development. It's all about managing changes to software artifacts throughout the development lifecycle. Consider it as the backstage manager, ensuring that all the different versions and parts of software are noted, tracked, and controlled. It's about version control, branching, merging, and release management. On the other side of the coin, we have quality assurance. This isn't about finding bugs or fixing them, but about creating a system where bugs are less likely to occur in the first place. Quality assurance is about establishing and enforcing quality standards and processes throughout the software development lifecycle. It's about conducting quality reviews, audits, and inspections to identify and correct defects before they become problems. In essence, configuration management and quality assurance keep the development process consistent and reliable. Moving on, we have software project management. This is the engine that keeps the software development train chugging along. It's the meticulous planning, scheduling, budgeting, and resource allocation that ensures all pieces of the puzzle fall into place. Let's start with planning. It involves mapping out the entire software development lifecycle, from the initial concept to the final release. It's about having a clear vision and a comprehensive roadmap for achieving it. Next is scheduling. It's all about timing. When should each task be started and completed? How much time is allocated to each phase of the project? These are crucial questions that scheduling seeks to answer. Then we have budgeting. This involves estimating the costs associated with each phase and allocating resources accordingly. It's about ensuring that the project delivers maximum value for money. Lastly, resource allocation. It involves assigning the right people to the right tasks at the right time. It's about optimizing the use of human and material resources to achieve project objectives. Project management ensures the project stays on track and within budget. Next up, we have software documentation. Now, this might not seem as glamorous as other parts of software engineering, but it's absolutely crucial. You see, documentation is like the DNA of a software solution. It's the comprehensive collection of information that tells you what the software is, what it does, and how it does it. Imagine you're handed a complex piece of machinery without an instruction manual. That's what it's like trying to understand software without proper documentation. Software documentation includes a wide range of documents, from requirement specifications that detail what the software needs to do, to design documents that outline how the software should be structured. User manuals guide users on how to use the software effectively, while technical guides help developers understand the inner workings of the software. In essence, good software documentation ensures that everyone, from developers to users, understands the software. It's a vital part of the software lifecycle. Software documentation provides a clear roadmap for developers and users alike. Finally, we have software ethics and professionalism. These are the pillars that ensure the integrity and credibility of the software industry. Adhering to ethical principles in software development isn't merely a choice, it's a necessity. It involves respecting intellectual property rights, maintaining privacy, and upholding confidentiality. Creating a software isn't just about coding, it's about creating responsibly. Professional standards, on the other hand, are guidelines that help software engineers to carry out their tasks efficiently and effectively. These standards promote quality and consistency in the development process. But remember, professionalism isn't just about following standards, it's also about continuous learning and development. Staying updated with industry trends, best practices, and emerging technologies is a part of being a professional software engineer. In essence, software ethics and professionalism are not just about doing things right, they're about doing the right things. They are what differentiate a good software engineer from a great one. Ethics and professionalism ensure the integrity and credibility of the software industry. To sum up, the scope of software engineering is vast and diverse. We have embarked on a journey through the dynamic landscape of this discipline, from the meticulous process of requirements engineering to the creative realm of software design. We've delved into the nitty-gritty of software development and the rigorous checks of software testing. We've learned about the importance of software maintenance, configuration management, and quality assurance. We've also explored the strategic aspect of software project management and the vital role of clear, comprehensive software documentation. Lastly, we've touched upon the significance of adhering to ethical practices and maintaining professionalism in the field. These components are not isolated, they are interconnected, each playing a crucial role in the success of a software project. Understanding the scope of software engineering can help you navigate and excel in this exciting field. Thanks for watching.